Alright guys, welcome to class. Today we are learning... Hey guys, welcome to class. Today we're learning about the universal law of gravitation. Today we're going to be learning about how you can change masses and distance to affect the gravitational pull between two objects. This right here is kind of a typed out version on what you're supposed to do, but I find it a lot easier if you explain how to do what we're going to do. So first things first, you guys will kind of see up here at the top, it gives you some background information on Sir Isaac Newton, who kind of came up with our universal law of gravitation. Here's our two overarching questions we're going to be addressing. How the mass of an object can change the gravitational pull on two objects in a system, and how the distance between those objects can change the gravitational pull between them. Okay? So I'm just going to give you these answers right here. Kind of reward those who are listening. A variable is any factor that can be measured or controlled. An independent variable, more specifically, is something that is manipulated by you, the scientist. And then, of course, a dependent variable is the one that we measure. In this situation, it's going to be gravitational force. So I opened up the simulator right here. This one right here is what you'll open up. So what they want you to do is they just want you to follow the instructions, right? So set mass 1 and mass 2 to 50 kilograms. So you leave them as they are otherwise. And we're going to set them to... Do you hear that kind of annoying noise? For class purposes, I want you to turn that audio off. It'll help people kind of focus a little more. Okay, there's 50. And let's set this one to 50. Awesome. Now, if you guys see up here, this number changes, right? This is how you measure gravitational force. So I only need you to write the numbers without the 0, right? So I just need 2742, all right? All right, so change, now that you've set that, change the distance of mass 1 to 1 meter and mass 2 to 9 meters. So we want mass 1 to 1 meter, and notice how the gravitational force is changing. You'll see that it's actually equal to both of these. And you'll also notice that it kind of went down a little bit. Okay? And that's all they want you to observe. What happened? Then they want you to change mass 1 to 5 meters and mass 2 to 6 meters. So we're going to move this one up to 5 and this one up to 6. And just write that number. It went from 27. Guys, it went up by quite a bit. It went up by about 80 times or so. Okay? So you want to kind of tell me that right here. That as you get closer, it seems like gravity goes up exponentially, which is what you can explain to me right here. What can you tell me about as objects get closer to them? What happens to their gravitational pull? Does the force go up or down? You're going to do the same thing down here. You're going to follow the instructions. It wants you to set mass 1 and mass 2 to 50 again. Okay, so they're at 50 now, so I'm just going to leave them be. Now you're going to increase the mass of 1. Oh, sorry. You're going to set the distance also. So we're going to reset the distance. Oh, we're going to move this one back down to 50. And this one to 50. And then we want you to leave them here. But now what we're going to do is we're going to increase the mass of one of them. And we're going to notice how it changes the force between them. And then you're going to manipulate it even further, okay? And then tell me how mass changes the gravitational force. Set mass 1 back to 50 and put it at a low amount, somewhere between 20 and 49 kilograms. Then decrease mass 2 again to an amount lower than 20 kilograms. So again, follow the instructions and tell me down below how it affects the gravitational force. Okay. Observe the directions and length of the arrows above the masses as you change the masses of the objects and change the distance between the objects. Make a claim about which direction the gravitational forces are acting on the objects in the system. Okay? So you're paying attention to these arrows right here if you look up here. These arrows are the ones that they're asking you to look for. And give me at least a full sentence for that answer. What are the 3 independent variables in this experiment? Well, I will give you a hint. There's only 3 things you can manipulate. You can manipulate distance, mass 1, and mass 2. As far as the dependent variable is concerned, as you manipulate these things, something changes. I'll give you a slight hint what, okay? The gravitational force. So go ahead and write that one down. So you're now going to do 2 experiments. One where you manipulate the mass, one where you manipulate the distance. So experiment and collect data on mass, okay? So start with both masses at 50 kilograms. That's what they are. Your independent variable, that's the one you manipulate, it's going to be mass. Your dependent variable then, as you change the mass, gravity becomes your dependent variable. Okay? Constants. You can temperature, all those other things that we've talked about, atmospheric pressure. These are all constants, but the most important ones that I want you to write down for this assignment are, as you can see, the mass is staying the same. Okay? Or, sorry, the distance is going to stay the same. So if you look right here, change the independent variable of mass 1, record the gravitational pull. You can leave off the zeros at the end. Remember I said you only need to give me these numbers. Start with 100. Go by 100s. Okay? So we're going to keep the distance the same. That's our constant. And we're going to manipulate the size. Okay? So you're going to manipulate and change one of the masses up to 100. You'll notice this little arrow helps you kind of get, so you can kind of drag, and then once you get close, oh, it looks like I got it. But this can kind of change more specifically so you can get the right amount. And then you'd write down the mass. Right there, there's 100. Now go up to 200. Write that down there. And 3, 4, 5, all the way to 1,000. That's it. And then you tell me what pattern you notice. As the mass goes up, what else goes up? Tell me. Give me a full sentence. You're going to do the same thing again, except now we're going to be manipulating. Remember, independent variables and manipulation. We're going to be manipulating the distance between these two objects, okay? So we're going to take this one back down to 50. Perfect. So change the distance and record the gravitational pull. You can leave off the zeros at the beginning and record the decimal place just like you did in the last one. Okay? So we're going to set M1 at 0. Why? Because it says it right here. So we're going to set M1 at 0 and M2 to the distance listed. Okay? So you're going to put M2 at the 10-inch mark. And you're going to record that data. Now we're going to go to 9. And you're going to record the change. And you're going to tell me, what do you notice about the change, how distance changes gravitational force? Does it go up or down as you get closer? And then give me a conclusion. And you're kind of answering those two big questions. How does mass of two objects affect the gravitational pull between them? And how does distance affect it too? And that's it, guys. That's the entire assignment. I know it seems like a lot, but it's not too challenging. Honestly, you should be done with it in about 40, 45 minutes. And obviously, you can email me with questions.